do now, I wanted you to use as many words in this word bank as possible to describe the function y equals x minus 4 squared minus 9. So thinking about what the number inside means, what the number outside means. And we could start with, like, is this a quadratic? Is it linear? Is it a square root function? And it looks like we could cross off linear and square root function. It's a quadratic. So this function is actually in what we call vertex form. We could say it translated 4 units to the right and 9 units down, which means the vertex is 4, negative 9, positive 4, negative 9, which also means the axis of symmetry is x equals 4. The parabola opens upward since it's a positive in front. There's no negative. It is quadratic because there is a 2 as an exponent. If something is squared, it's going to be quadratic. And to find the y-intercept, the y-intercept is when x is 0. So I'm going to plug in 0 in for x, which is here. And then when we simplify, 0 minus 4 is negative 4. Negative 4 squared is 16, so that's here. And then minus the 9 gives me 7. So the y-intercept is actually 0, 7. And then the increasing, decreasing. So the axis of symmetry is where it changes from increasing to decreasing. So it's decreasing for every x less than 4, and then increasing for every x greater than 4. It switches at the axis of symmetry. I'll be making a homework number 6. That'll be due Thursday, so stay tuned for that. Now, what we would want to do is to graph this equation. We just saw that the vertex is positive 4, negative 9. So we could go to positive 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that is here. And then we also saw that the y-intercept was at 7. 1, 2, 3, 4, 5, 6, 7. Okay, so what we could do is you would have your graphing calculator, but again, the equation was y equals x minus 4 plus 9. You can also just plug in numbers for x and solve for y, and that will give you the y values. So if we were to plug in the number 3, 3 minus 4 is negative 1, but negative 1 squared is positive 1. 1 minus 9 is negative 8. Okay, because this is the axis of symmetry, let me draw a line in here. I'm going to put in a dotted line. That is blue. So that is here at x equals 4. You can then reflect all of these points across the axis of symmetry. Since this y-intercept, which we found on the other screen, is 4 away, I'll go 4 over here. And then we could use a few more points. If we were to plug in 2, 2 minus 4 is negative 2. Negative 2 squared is 4. 4 minus 9 is negative 5. So when I plugged in 2, I get negative 5. And we could also look at that pattern with parabolas. This is going up 1. This is going to go up 3. The next one should go up 5 units. So I could just double check that here. Let's plug in the number 1 and see what we get. What's 1 minus 4 is negative 3. Negative 3 squared is 9. 9 minus 9 is 0. Okay, so we have the point 1, 0, and then reflecting over, we get the point 7, 0. So we could also plug in 7 and you should get 0. So what we call these points, and then we would want to connect these best as possible. Now I'm using my mouse, so it's not going to look fantastic, but good enough. Okay, so what we call these points here, these are the x-intercepts. If this point up here is the y-intercept, these two are the x-intercepts where it hits the x-axis. we have two names for these. We call them either the roots or the zeros. Why do we call it the zeros? Okay, it's when the y coordinate is 0. Okay, so to find the x-intercept, it's when the y coordinate is 0. And where do we look? We look on the x-axis. So please fill in your sheet. And remember, you could pause the video at any time. One thing that I wanted to point out that is significant, if you look at the axis of symmetry, where is it in relation to these two roots? So if you notice, one root is 3 units to the right in this case, and the other root is 3 units to the left. So the axis of symmetry is always between the two roots. Okay? So given the parent function, y equals x squared, what key features of the function would change if it were translated down 4 units and 6 units to the left? Think about all the key features we've discussed today. Okay, so I would say that the vertex would move from 0, 0, which is regular x squared, and 6 units left, which means go to -6, and down 4 units, which means -4, which would also mean the axis of symmetry is now x equals -6. It would also shift where it's increasing and decreasing, etc. Okay, now what is the equation of a function that is shifted down 4 units and 6 units to the left? So I want you to think about what you do. Go back to the do now, which is here. This was moving right 4 units and down 9. So how are we going to go now 6 units left and down 4 units? You should have an equation that looks like this. To the left means +6 and down is -4 still. Explain how you're able to write the equation. Again, changing the sign of the number attached to the x. Left means plus, minus means, and right means minus. To move down, you put the number on the outside and subtract that number. And if you were going to move up 4 units, you would put a +4. Does the function open upward or downward? And describe when the function is increasing or decreasing. Well, because there is no negative in front, the parabola is opening upward. And then it's going to decrease when x is less than -6 and increase when x is greater than -6. So here's our visual. So the vertex is -6, -4. There's your axis of symmetry. So it is decreasing, meaning going down, kind of like a negative slope, for every x value less than -6. And then it's increasing for every x value greater than -6. Okay, how could you rewrite this function so that the vertex stays the same but it opens downward? So you would simply just put a negative in front of the equation. So that negative will go here. So let me show you what that will look like. So if we put the negative in front, so the black graph is the regular, the red graph now has the negative. They still have the same vertex, but now this one is down. Okay? So the number in front does not affect the vertex. It's simply the number inside and the number outside that determines the vertex. Okay, we had these two questions here. It says the zeros of the function 2x squared minus 4x minus 6 are, is it 3 and -1, 3 and 1, -3 and 1, -3 and -1. So these numbers are very similar. What do they mean by zeros? It means where does the graph hit the x-axis? So because we were supposed to have our calculators in class, what could we do without a calculator? We could plug in the answer choices, and we want to see what will give us 0 for the y value. So when we plug in, we should get 0 for y. So let's look at that. If I plug in the number 3, 2 times 3 squared minus 4 times 3 minus 1, so this is 9. 3 squared is 9, times 2 is 18. Then this will give you -12. So 18 minus 12 is, what is that, 6? Oops, I made a mistake. I just realized this should be -6. This should be -6. Okay, so now we have 18 minus 12, which is 6, minus 6 actually does give you 0. So this is 0, which is good. So 3 is an answer, which means I could cross off 3 and 4 because 3 does work. Now we have to check if -1 works or +1 works. So if we look at that, -1 squared is +1, times 2 is 2. -4 times -1 is 4. So that's a +2 and a +4, which is 6. Minus 6 does give me 0. So both -1 and 3 gives me 0, so the answer is that. Okay? It says explain a method you could use. Well, if you had your graphing calculator, you could do two things. You could graph the equation and look at where the graph hits the x-axis, and you would see it hits at 3 and -1. Or you could look at the table of values and see when y equals 0. Okay, so let's look at this graph and see what's going on. Okay, so this is the graph you would get. You could see it is hitting at -1 and +3. And that would be your answers. Those are the zeros or the roots. Okay. Note, I want you to note the axis of symmetry is always right in the middle of the two x-intercepts. So if this is 4 spaces away, 1, 2, 3, 4, halfway is 2 spaces away. So I actually can draw in the axis of symmetry, and I'll do that in, let's see, we'll do purple. Okay, so the axis of symmetry would be here when x equals 1. Okay, so 2 spaces and 2 spaces. So that means the vertex is also when x equals 1, and in this case the vertex is 1, -8. So when it's asking when is the graph increasing and decreasing, it always changes at the axis of symmetry. So therefore, it's decreasing when x is less than -1, which is here, and then it is increasing when x is greater than -1, which is here. And lastly, we have this question. If the function f of x equals parentheses x minus 2 squared plus 4, the minimum value occurs when x is. So minimum value, when you see that, you have to think vertex. And if you look at this equation, it is in vertex form. But let's say in June you forget all of this. One thing you can do is you can graph it and take a look at the graph. Okay, but because it is in vertex form, and we should know it's in vertex form, the vertex is +2, +4. Okay, because you change the sign with the x and keep the sign outside. So this vertex is actually a minimum point because it's a positive in front, and you were to graph it. Okay, so +2, +4. The graph is going to look something like this at +2, which is, let's say, here, and +4. So if I were to do 4 tick marks, okay, this is obviously not to scale. Okay, so +2, +4, and it's opened upwards. That's your minimum. And this is saying at what x value? Okay, notice they have 2 and 4 as answers. Okay, but they want just the x value, so that is +2. Okay, so how did it transform from the parent function? I would simply say it moved right 2. Okay, the transformation is just like the vertex. It moved right 2 units and up 4 units. And the axis of symmetry is hiding in here. It's actually the same as the x value of the vertex. So it would be x equals 2, the same as the vertex. Okay, so tomorrow I'm going to give you an exit ticket, which will actually be an entrance ticket. I would have given it to you today. So make sure you go back and you review all these properties and make a connection between how a graph translates left, right, up, down, and the connection it has with the vertex. Okay, so go back and study all of this material, and I will see you tomorrow.